Chain, chain, chain. 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 Chain, chain, chain of food.
The section's on 3.6 chain rules. So in pre-calculus and also in algebra 2, we did this thing called the composition. So what does that look like? So we have as g of f right here. Remember, it's an open circle right there. And we said that g function is inside the f function right there. Okay? So in calculus, what we're going to do is we're going to take the composition and we're going to take the derivative of that. So we're saying that that function, the composition function, is differentiable. So what does that look like? So now we're going to take the, notice that little derivative notation right there. So we're going to take the derivative of f right there. Notice the g function is remaining right there. We're going to multiply to the derivative of the g function right there. So that's what this is right here. Okay? So let's try an example. But before that, let me give you a riddle. What does a chain rule, an ogre, and also an onion have in common? Yes, they have layers. So similar to that, we're going to have some layers when we do the chain rule. Think of it as like an onion. You're going to have some layers involved in this, okay? And it can also make you cry if you don't do it correctly. So here's an example 1. So example 1, here's my parentheses, like my onion right there. So make sure you have enough parentheses when you do chain rule, okay? So we're going to take the outside layer right here. We're going to bring down the 2, subtract 1 on the exponent. So this is what it looks like right there. Then we go inside layer right here. So here's my inside layer. We're going to take the derivative of 3x squared, which is the 6x. Derivative of 1, which is a constant, so that disappears right there, right? So we're going to multiply to that right there, so there's your 6x right there. So what you're going to go from is the original to this first step right here. This is right here is just to show you that first layer, but eventually this is where you need to go from here to here, okay? So we just need to simplify the 6x by bringing it up in the front, multiplying by 2. That gives us 12x. I distribute the 12x into each part of the parentheses, and we get 36x cubed plus 12x. If I can combine like terms, I combine. If not, this is your final answer right there. Okay, let's try an example number 2. So example number 2, I have as a tangent. Then I have all of this other part right here. So the tangent is my first layer of that, the chain rule right there, or the onion right there. Then notice the parentheses. So here's my second layer right here. Up to this point right here is my second layer. Okay? Then my third layer is right here. So you got to make sure you have enough parentheses. Especially in the textbook, it doesn't a lot of times have, on the trig functions, is the parentheses. So for this part right here, make sure you put enough parentheses when you do it for classwork. Okay, so here's our first layer. So derivative of tangent is secant squared. So I copy all of this right here. Now I take the derivative of the inside. So derivative 5 is a constant, so that disappears, right? That's a 0. Derivative negative sign right there will give us negative cosine. So I multiply to the negative cosine right there. Notice I copy all of this right here, copy all of that. Now I take the derivative of the 2t, which is 2, right? So here's my 2 right there, okay? So we're going to simplify. We're going to bring the negative and the 2 up in the front, and then we're also going to bring the cosine just because there's a single exponent right there, and then push everything in the back. Okay, let's try example number 3. So example number 3, we're going to have some radical equations as well. So just fix this equation up as we learned from the derivative. It's easier to work with exponents because then you can take the derivative using the power rule. So this is what it looks like right here. So we just change it to the half power right there, okay? So same rule goes, we're going to bring the half down, we're going to subtract 1 on the exponent. So that's our first layer, which is right here. Second layer is just the cosine part of it, and then the plus 2 part of it. So the derivative cosine is negative sine. Derivative of 2, it disappears because that's a constant right there. So we're going to multiply to the negative sign. And then the derivative of the inside layer right there, which is a 1 in this case. So it's not going to affect the equation. But if there was a number, you would multiply by that number as well. So I'm going to bring the negative sign up in the front. I probably should have put parentheses on that negative sign because it looks like a minus sign instead. So we'll just bring it up in the front. We have as negative half sine x, and then the cosine x plus 2 to the negative half power. Okay? So those are the examples that we're going to do for the chain rule. So just be careful and make sure you have enough parentheses and make it look like layers.
For your information, there's a lot more to ogres than people think.
Example?
Example? Okay, ogres are like onions.
They stink?
Yes. No.
Oh, they make you cry?
No.
Oh, you leave them out in the sun, they get all brown, start sprouting little white hairs.
No. Layers. Onions have layers. Ogres
have layers. Onions have layers?
You get it. We both have layers.
Oh, you both have layers. Oh. You know, not everybody like onions.